Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Karel D'Oosterlinck to the Weaviate Podcast. Karel's a PhD student in NLP at the University of Ghent and a visiting researcher at Stanford University, where he's put together currently the most advanced DSPy tutorial out there. It's a super cool use of this, inferring the labels to then retrieve and then rank this extreme classification taken down with language models. Karel, I'm so excited to be welcoming you to the Weaviate Podcast. Thank you so much for joining.
Thanks, Connor. Yeah, I'm very excited to be here. Thanks.
Awesome. So could we kick it off with the problem that we're solving with DSPy and extreme classification?
Yeah, so extreme multi-label classification, it's a problem where you're trying to, apply a fixed set of classes to maybe an input document, but there's an extreme amount, like over 10,000. So, as an example, one of the tasks we tackle is kind of encoding job vacancies. So a lot of people put job vacancies online, and the European Union actually developed an ontology of like skills, competences, occupations. And that is, it's very nice if everybody can speak that same language. Of course, people don't always write vacancies with this ontology in mind. So looking at vacancies and figuring out how to map it to that ontology is like an important problem. Or, for example, in biomedical NLP, there are huge ontologies, enumerating all types of medical reactions, all types of drug-drug interactions, all types of like active substances in drugs. But, when doctors write papers or when they write clinical notes, we're not expecting them to, perfectly adhere to this ontology all of the time. So it's really important to get medical papers into this ontology so that when we need to search over the existing literature or when we need to do like statistical analysis, we kind of have those agreed upon labels. So yeah, that is mainly the idea behind extreme multi-label classification. Yeah.
Yeah, so I love that. In Weaviate, we have filtered vector search where you'd apply like a filter to the vector search, so we have this kind of like tagging the scientific papers with these terms and something that we could use with vector search. But I'm just so fascinated with how you've this idea of trying to prompt language models to do 1,000 classification. It really breaks my brain because I understand like usually when we're talking about using LLM for filtered vector search, we're talking about like parse this query and then add like who this, like say the query is like, information about DSPy where the speaker is Omar Khattab. It can like parse the query and then populate that class. They only have like, 50 speakers in my data set. But so I'm so curious, how do you prompt LLMs to do 1,000 classification?
Yeah, the general idea is that LLMs probably get the gist of the task. Like an LLM probably, I don't want to anthropomorphize here, but like an LLM can probably be prompted to be very good at saying, looking at a vacancy and saying like, oh, this is clearly a job application for a Python programmer. And the person needs to also be familiar with Scrum agile development. Those are all concepts the LLM has prior knowledge of. The problem with these ontologies is that maybe Python programmer is not an exact entry in this ontology, but it might be Python brackets computer programming, right? So the idea is that the language model probably can be prompted to do this, but it's really grounding to the ontology that causes a lot of issues. So maybe the naive first thing that you want to do when you have 50 classes is you just put those in the prompts and you let the language model pick out of them. You're like, hey, these are the options. But how do you do this when there's like 10,000 ontology items? And maybe, every ontology item has a description. How do you put 10,000 labels and descriptions in a prompt? Seems kind of excessive. Even with really long context models, that would just be a huge prompt, making you pay a lot for inference. So really our idea was, let's just try to get the model to get the gist correct, then zero shot map whatever the model predicted on the real space, then kind of get a short list, and then do that final, here are the options, re-rank them, filter them out. So there's basically two ideas there. So one is indeed that you need this kind of pipeline or this program, this orchestration of inference and retrieval to solve this task. And another idea is we really want to use zero or few SHA components. We don't want to train a specific retriever for every type of extreme classification problem. We want to rely on the flexibility of a language model to like adapt to any task based on a few demonstrations. And then we want to rely on some general knowledge in a pre-trained retriever to, make it scalable and match whatever the language model was outputting into this space.
Hmm. It's so cool. I love the connection with the vector search and how it's used to map it into the ontologies. It's really novel. I can't say I have another example. I guess something that inspires my thinking is I really like this project, the Gorilla LLMs from Berkeley. And I mention this on the podcast all the time, but I love this idea of like the LLM formatting API requests. And then there's this
Yeah.
problem of like, okay, well, which API do I use? And you can imagine the API zoo having thousands of APIs, and so you first just have the LLM like, give a sense of what kind of tool it wants, and then you map that into what you do have with the embedding search. It sounds like that's kind of like the
Yeah.
plan here.
That is exactly the idea. And I love that you brought this up because I was just this week talking to a student at Stanford that also was using LLMs to aid programming, but in like very esoteric APIs, like in a programming language the LLM doesn't just do out of the box. And indeed, it's the kind of the same extreme multi-label classification paradigm. I'm not saying it's a full solution there, but it's definitely a very good first step, right? It's okay, we're going to have the model just in natural language try to describe what kind of behavior is needed to solve this problem. Then we're going to do a search and we're going to offer this to the language model. So really my long-term hope for this work, this Infer-Retrieve-Rank or IReRa work, is that researchers put a lot of smart ideas and inductive biases into how do we solve this general problem, and then you want to use it to formulate SQL queries. You apply IReRa there. You want to use it to extract chemical substances from biomedical literature. You use IReRa there. And behind the scenes, a lot of the ideas, the technical ideas of how do you learn to rank, what parameters do you optimize, which teacher and student models do you use, that should all be abstracted for you.
Amazing. And so I guess the raw part and the I rewrite rounding out the program before we dive into the compiler is so you've retrieved and now you have the ground truth, like not ground truth, but like you have chemical reactions that are in the ontology, and now you're re-ranking them with the query. Is it just I think because this is a vector search podcast, so I think most of our listeners understand re-rankers. So I just kind of confirming that that's what's happening. Is that correct?
So that is what's happening. Currently, this is just being done with an LM. So, we have the inputs. A first LM will predict queries. Queries result in retrieved items. And then the input and the retrieved items go into a final prompt where, you take the top 100 scoring items and you ask an LLM to filter out anything that's not applicable. And this is really important because the retriever is frozen. So that means that the retriever is, let me give you an example. In these job vacancies, sometimes we see a job vacancy that says you need to be good at, software architecture. And then the LLM outputs a query surrounding software architecture. And because of we're using a frozen retriever, it'll just find a lot of architecture skills. It'll match very strongly in architecture. And then it'll be like, oh, for this vacancy, you need to like understand building architecture. So then, another LLM is like, no, this clearly was wrong, filters that out. Yeah.
Got you. Okay, super cool. So I really am so curious about the DSPy compiler now. So we have the so maybe we could start from the beginning. Work our I think so. Infer is parametric, retrieve non-parametric, and then ranking parametric again. So could we kind of describe like how that infer part is optimized? How like I understand DSPy has like a signature optimizer as well as like the bootstrap examples. Could you kind of take us through like the whole how it works?
Yeah. Yeah. This was very fun for me to learn and play with. And so I guess the idea that DSPy tries to embody there is you can play with the prompt, right? That is what people are
Mhm.
doing. but people are doing it in a very messy, very iterative prompt engineering way. And if somebody says like, "Oh, this prompt is perfect on my task," and I have a slightly different task, there's kind of like no way for me to take that and just apply that. So the DSPy idea there is you start with like a minimal seed prompt or a signature, right? Something that just defines what the task should be. And then you layer optimization on top to figure out what is actually the best instantiation or the best like derivative of this prompt for performance. So in the work that we've done, this involves finding good demonstrations. Um, so you might have some unlabeled inputs, and what happens is a very strong, like a teacher language model, tries its best to, solve the problem on these inputs. And if it's successful, we will consider like the intermediate outputs in that pipeline as demonstrations for a student model. So that is one way, and that is what our current results reflect. But the nice thing about the modularity, I would almost say the paradigm shift that DSPy offers there is this optimization logic is separate from all the implementation work you are doing as a developer. So I think the optimization space, like the space of these algorithms, is so underexplored. I think like for the next months, it'll always be like somebody finds just a better heuristic for teaching a student for finding good demonstrations. And the idea is, I changed nothing of my code base. I just pointed towards a different DSPy compiler and my performance goes up. Um, in the same way that program your language model in PyTorch and you can point it towards the Atom optimizer, or then you point it towards Atom with weight decay and that ends up being better.
Yeah, I love that analogy. The whole, yeah, like Atom, now SGD, or I think like Nestorov. I don't remember all the optimizers that well, but that kind of analogy is so exciting. And I love how you named your repository XMC.dspy, and it's like a general program for extreme multi-label classification. Amazing. And so sorry. So before, I really do want to, we've got about an hour podcast here, so buckle up. And I want to firstly just make sure I 100% understand that the infer task. Are you, when you're trying to, like, your measure of performance, should it try to put something on the ontology right away, or should it try to? Yeah.
That's a really good question. That's a really good question because ideally, no. Ideally, you want a system that can learn to write queries that are not part of your ontology, that at the end maximize your accuracy on the ontology. The reason why I'm for example, saying this is a colleague of mine from Ghent University. They have like a biomedical retriever that's actually trained to match descriptions of ontology items with ontology items.
Mm.
And you can imagine that if you use that one in the middle, you actually don't want your infer module to just say COVID, right? You want your infer module to actually describe the symptoms the patient is having maybe in the biomedical paper, because matching performance will be higher, ideally. But the bigger question there is, how do you get supervision in the middle of these pipelines?
Mm.
Like if you say that you want your infer module to just be correct directly, well, then you already have labels there and you can optimize the infer module separately. But if you're saying like, hey, the infer module should be able to output any kind of query as long as they lead to good performance, well, then of course I think your maximum performance of the system will be better, but your search space is much more complicated. So you need to, it then becomes really interesting to think about what kind of heuristics will I use to, teach or to like find good demonstrations for these steps where I don't actually have real labels for.
Yeah, I think there's just so much to that. But so my general understanding is that with DSPy you kind of optimize the modules sequentially, like top down, like whatever is closest to the input, that's optimized first. Is that but then it's the farthest from the supervision. Because I imagine you could supervise the. I like what you said about you could just take the infer part out and optimize maybe just that prompt with the ground truth of the ground truth reactions. And man, yeah, sorry, the question's not super well formed. I'm still trying to piece this together. Just
Yeah.
is it top down that the optimization works, or is it sort of, I guess, bottom up? Like,
Yeah. So uh, I guess, the optimization can work any way we want it to. The I think the current paradigm of how it is being done in DSPy, but of course that is rapidly evolving, right? The
mhm,
current paradigm is, hey, we take this entire logic and we give it to like a teacher language model, like
yeah.
GPT-4, and we run entire examples through the pipeline. And the examples that GPT-4 was able to resolve zero shots, we kind of know that the intermediate steps were good,
Oh, okay.
right? So it is indeed like left to right in some sense, where every module probably introduces some error and there is some like cascading error. But if at the end of the day the model produces something good, we kind of label that as a good trace, and then all these intermediate steps can come on the student. However, that is only one way to do it. You can imagine that if your pipeline becomes very, 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 very long, the kind of, the compounding of all these errors makes your signal really noisy. So you could do a type of different idea, which is maybe more of a backward pass through the pipeline, where, maybe you start with the labels and the task of the last step, and you try to have a teacher language model kind of reverse engineer what the input would have been. Maybe so you tell the teacher like, hey, I just need a query that will resolve in Python programming that would be compatible with this input. And then you can walk, right to left through this pipeline. And then you can go even further. What if we want to optimize left to right and right to left at the same time? What if we have really deep pipelines? We could apply something like a skip connection, right? We could maybe say something like, hey, in the middle of the pipeline, do your best to produce the actual outputs. And then you could like short circuit the optimization flow so that you also get some signal in the middle of the pipeline. Those are all like things that are possible in the DSPy paradigm. I think they definitely need to be rigorously studied. But currently, we're more doing the forward thing, where we're just pushing examples through the pipeline, and if they resolve, we consider them. We consider the whole trace as potential candidates for the prompt of the student.
Amazing, Karel. Thank you so much for that. That just really helped my understanding of it all. And I'd have to clip that one out, and we'll put that one on social media as well.
Nice.
I yeah. So wow. It's so I guess that whole idea. I mean, what really made it click for me is just you run the zero shot through the full thing, and that's a good example, and that gives you supervision for the intermediate. I think most people who are on my level of just kind of now wrapping their head around the DSPy
Hmm.
compiler, I think that would be the one that would stick with them. The skip connection thing, to me, it did really trigger my imagination, but it's like I'm still trying to, like, this whole like intermediate supervision thing is still hard for me to kind of connect the dots on. I guess like if we maybe come into, so I guess I guess they're kind of like two things we could look at. We could be thinking about like 6 layers of LLM programs, or we could maybe if we could first just kind of ground this infer, retrieve, then rank a little further, and then maybe dive
Hmm.
further into a really deep program.
Sure.
So we have the infer. Now we're re-ranking, and so we just trace through it zero shot, and then we have some examples. Is there anything like how to now say like the bootstrap Optuna, where there's like a Bayesian optimization part to it? How does that then come into that picture?
Yeah. So I've been experimenting with the Optuna. I haven't had the time to fully delve into it because, the actual paper deadline for this IReRa work is coming up. So I'm focusing on making the results that we have more
Right.
rigorous. Um, so I think I'd let, the authors there could give you the people that actually wrote that code can give you a much better insight. But how I understand it is, you're doing discrete search in some sense. You're
Mhm.
searching over which demonstrations do I put in the prompt, but you could also be searching over, which words do I put in the instruction. All of this
Mhm.
is kind of like discrete, pick words out of the vocabulary or pick and demonstrations out of the training
Mhm.
data set. Um, and the way the DSPy optimizer now works is based on a random search, right? Or the one that I'm using. It'll like take 10 candidate programs. This is a hyperparameter based on your computational budget. And it'll like try 10 random samples of demonstrations, and the one that works best on validation, well, that's your program. But of course, it becomes much more complicated because maybe two demonstrations are both individually very informative, but once you have one, the
Mhm.
other doesn't really add information anymore. So, this just really becomes this deep kind of discrete search problem. And you can start modeling all of this with like Bayesian optimization and trying to like figure out what is the effect of, this demonstration given these demonstrations. Um, and I think that's what they're trying to achieve there. I'm really excited to get more time to actually get that working. Um, because yeah, that's fair. It's just very exciting to really apply a lot of the rigorous discrete optimization techniques here. Yeah.
Yeah, amazing. Maybe a quick question for you is, would the examples be input dependent? Like maybe or is it just kind of one set of examples is going to be the best one for the pipeline?
Um, that is interesting. I've been thinking about that as well. I think it depends on what type of data regime you're in. So let's say you just have, in our extreme classification tasks, you can have like 30,000 classes. Let's say you have 50 examples. You're nowhere near covering even a fraction of the label space. So there, it would make more sense to try to figure out which examples are just of high general quality and put the model in a state where it kind of produces the correct queries. And then you have that prompt, then at inference time, it's fixed. You can imagine that once more data comes online, you actually enter a regime where the moment you get a the moment you get a vacancy about like programming, you can actually go consult a database of examples where you have good labels for, and you could actually like, pick the 50 ones that are related to programming, and then maybe either put those in the prompt or like do another search and turn that into like the programming prompt. This is the prompt every
Mm.
time we use to cover like a tenth of the skill space when we think the skill space is about technical skills. Um, and that kind of ties in with a larger idea around the whole DSPy work that I'm really excited about. It's really depending on how much data you have, the set of strategies to solve a problem differs so much. If you have a few data points, the best thing that you can do is you can, take pre-written prompts offline and, do that. If you have maybe 50 data points, the best thing to do is maybe what we do now, hopefully, is kind of decide on a very good general prompt. And more data, it might be dynamically constructing prompts. Even more data, it might be like, let's consider fine-tuning the retriever.
Mm.
And an excessive amount of data might be, let's collapse this entire system into like one specialized retriever, if that's desirable. But yeah, so I guess it depends. I think I'm very eager to try this and to add this to the IReRa software. Um, but I guess it's currently not the data regime where I'll be able to measure if this works really well.
It's it's all like so new and exciting. I hope that like for our listeners, we're trying to have like kind of a sequential narrative of it, and I think there's just so many ideas to kind of wrestle with. There's kind of two questions. I like you mentioned earlier, kind of like the interaction effective examples. Like yeah, you have two good examples, but maybe together in the prompt they're not as good as a combination of the good example and some third example, and But the question and I think that is something that we could definitely double click on. But I really want to ask this question about kind of like information and examples. Like if I'm doing extreme classification of drug reactions, I might imagine that instead of putting examples, I might want to put like, a paragraph about the drug reactions, right? So where would that kind of fit in of like putting information in the prompt as well?
Yeah, so probably that would fit later in the pipeline because you already want to have a short list of potential candidates. And then maybe in a ranking step, you want to, everything that's not obviously wrong based on the name of the label. Maybe you want to do an additional ranking step where like, okay, we're going to take the top 20 candidates and we're going to take, a very strong language model and we're going to give the language model actual medical agreed upon definitions.
Mm-hmm.
And now it needs to do in context reasoning to figure out whether it exactly adheres to this definition or not. So that is very exciting. The thing there is you're also, you're compounding these pipelines. So you're adding new calls. So it's also more expensive.
Mm.
So something I care about here is, if we just want the best performance, the pipeline that's going to do the most GPT-4 calls per test input will kind of win. But if you're paying $5 per inference, that's just completely unusable for any real world application. So I think another interesting thing about DSPy is if we're all building these systems in the same framework, we can start measuring, more costs and get a better sense of the overall utility of a pipeline.
Oh yeah, that's absolutely one of the things about DSPy that excites me the most is I guess for me there's two things here. There's like you could fine tune a smaller model, like you can fine tune maybe, and I guess that question remains to be answered, like how small of a re-ranker can we have and it's still effective? But then I guess the other thing to me that's incredibly powerful, especially with like Ollama making like Mistral models really fast, is like could we set up like I feel like DSPy is about optimizing this perfect prompt that could result in even like Mistral 7 billion parameter model being able to complete the task.
Yeah. Mm, yeah. So I guess my opinions of it as just somebody that uses DSPy is I think finding the perfect one singular prompt is nice and it is very important. Um, but like you've previously said, I think it could as well be that for some types of tasks and for some amounts of data, it makes more sense to maybe have half of your examples in the prompt fixed and the other half dynamically based on retrieval similarity retrieved so that the model is exposed to similar examples in
Mm.
context. Um, that's a trade-off because you're paying more retrieval costs at inference and you're probably increasing your latency a bit. But that might as well result in better performance. So
Yeah, it's so interesting you say that because I actually think that could be a massive application of vector databases and vector search is finding that similar example and having embeddings of examples. Yeah, all that is so cool. So maybe if we could also, so I think there's, sorry to be maybe backtracking too much, but there's kind of like the signature optimizer, which is like how you, present the task to the model to begin with, as well as kind of the examples. And can we maybe zoom in a little more on the signature optimizer and how that works?
yeah. So I wasn't in the loop on that signature optimization work. So I just want to say probably Omar and the students that were working on that are, maybe, candidates for a next episode. Um, and I think there's a paper coming out very soon. So, but yeah, I guess the idea is just that not all not all wording one wording of the task is not optimal for all models. Um, and for example, when Omar and I were starting to work on this extreme multi-label classification problem, just one of the first things we did, this was actually a really fun hackathon. He was kind of DSPying his way through this biomedical data set, and I was like manually prompt engineering my way through the data set. And one common pitfall for some of these smaller models is the output format. Sometimes you just really have to emphasize that you want a comma separated list. And you can imagine that, signature optimizers are good at that kind of stuff. Maybe you really want to allocate your like demonstration budget towards really like deep rationales, hard thinking about the task, and kind of exposing the model to all of this biomedical context. And maybe it's more compute efficient to just figure out how to optimally in the instruction, how many exclamation marks to put after give me a CSV. It's kind of funny, but also that is kind of how people are prompt engineering this. It's like, if I put CSV in all caps with like 5 exclamation marks, then Llama does it. And then, then I can parse my outputs. But it feels like we might not want to spend human ingenuity doing that.
Yeah, I guess the kind of parallel about that one makes me laugh because it's like we compiled it all night and it came up with this really terrifying threat to give to the language model to force it to output JSON. It's like, but I do agree that in my experience of prompting the language models, saying like please or very important in all capitals. This is like how I've achieved structured output parsing. And I do want to give a hat tip to Jason Lewin Instructor, and I think what they've done with the schema validation is super cool. But then I still think you do need all this like very important. Please follow the syntax to like retry. Like you would use the pydantic thing to check if it passed if the output passes the schema, and if not, now you need to retry it. And the retrying, I think it's time to break out the.
Yeah, and it just like a natural thought arising now is, what is the optimal way to do that? Probably like, if maybe even, with how efficient fine tuning is also becoming, and the fact that if you want to focus on formatting, you can generate synthetic data. It might make sense that formatting, maybe down the line, that's something that we fine tune against. Like, this model always needs to return a CSV or my program will, explode. And maybe the most efficient way is not begging it to do so, but the most efficient way is like a very targeted update, maybe with a low rank adaptation. That all remains to be seen. But it's interesting that we're instead of just like fine tuning, we now have this whole spectrum of approaches towards getting what we want out of these models. So kind of studying that across tasks, across like data regime, across models is going to be very valuable, I think.
Yeah, I love that you mentioned that we have all these different tactics, and I did want to give another hat tip to Derek Kleczek from Weights and Biases. I had asked him, I said, what are people fine tuning large language models to do? Because Weights and Biases, right? They see all the what people are doing, and he had told me that it's really about like this following some kind of structured output or changing controlling the style. And I've done some experiments with AnyScale's fine-tuning APIs with this formatting Weaviate GraphQL queries, and I've seen for myself that it is very good at following an output with fine-tuning. And yeah, maybe fine-tuning is the best way to achieve the structured output. I guess I'm curious, when you do so with DSPy, it would come up with examples of following the output format. Like if you need a list of ints, right? And how well does that work in your experience? Is that like I know it's kind of maybe hand wavy to say have you run it in 100 different but
I mean, so I've only been working on expecting the models to get like a comma separated lists. Typically, zero shot at GPT-4 is really good. Ollama zero shot will fail sometimes. It'll maybe give me more of an enumeration and bullet style, and then the question is it me as the program developer to account for all these things? Um, or is it the optimization procedure that needs to rule this out? And honestly, Omar probably has some like deep philosophy, like deep ideas on this. I'm not really fully sure because I think if my optimizer ends up picking a few examples that teach Llama to follow the structure, I'm kind of like, okay, I'm very glad this happened out of the box, but I really want to use my examples for like deep information about the task. And if I could have gotten the same types of performance increase by just making sure that my parser also handles, new line lists with bullets, maybe, the optimizer could have done more interesting things. So, um, the best pipeline probably for a specific task is at this point always going to be the one where like the most human engineering still went into it. I think that's just how research in general kind of works. But really, I guess with IReRa, the hope is really that, I supply the parsers for CSVs, but they can also handle enumerated lists. And just all of the like common pitfalls are already guarded against in the pipeline. And then the optimizer can like be really good at just finding examples that give good information for the task.
That's such an interesting entanglement. The output and pivoting topics a little bit. I really wanted to zoom in on the teacher student kind of model. I
Mm.
know in the Rank Zephyr paper, what they do is they have like a 2-stage fine tuning where first you generate examples with GPT 3.5 and then GPT 4 because and then stage 2 is GPT 4 because it's cheaper to kind of do it that way. How do you think about that kind of like which teacher model? Because I know GPT-4 is probably always or maybe Gemini Ultra is in that category too. Yeah.
Yeah, absolutely vital, paramount, I'd say, to get this to work in the real world. Uh, you've hinted at it, taking the biggest, baddest language model and, paying most of your university funding towards the API is going to give you the most state-of-the-art papers. But really, we shouldn't keep pretending that accuracy is the only utility we want to do research for. These are all systems. They all have latency. They all have a number of calls. They all have memory requirements, and they all have costs associated with them. And honestly, it is within that space that taking all of that into account where a lot of really interesting research happens. So how I experienced this during the experiments I've run for the paper and the experiments I'm still running is that inferring with Llama as a student model, so having a student Llama 7 billion, the Llama 2 chat version, predicting queries works really well. Having that Llama do re-ranking is pretty bad. So there, it's really crucial that the re-ranking happens by a GPT-4 model. And that is now a target for ablation. If somebody else can actually figure out like, oh, we're going to train a rank llama and we're going to use this rank llama, and now it actually is good at ranking, and it works across a broad sweep of these tasks, well, then their contribution really generalizes and provides a lot of utility across all of these information retrieval tasks. So that's just to kind of reflect how I think about these model choices. I'll give you another interesting tidbit that's not in the paper yet, but we found that when we're optimizing the first Llama module, actually it does worse with a GPT-4 teacher and it does better with a turbo teacher. My current hypothesis is actually that GPT-4 gives a very complicated rationale, and Llama has trouble following that. Whereas the turbo rationale is actually pretty straightforward, and Llama kind of adopts that straightforward rationale. So, so that's maybe not intuitive to really show you that there is study that needs to be done as to which model can provide bootstraps for which other model. Maybe like the best thing in the end is like we'll have GPT-4 do the task, but then like, hey, write a rationale and explain it like I'm five. And then that gets mapped to Ollama to like account for the capabilities that student has. So there's a lot of non-trivial interactions between all these pieces, but you need to take them into account because otherwise you're just going to pay $5 or whatever I'm just saying a number here, but you want to cut costs and you want to do this also locally. I've had medical experts, pinging me on Twitter, being like, "I want to apply this on my data set. We can't use GPT-4 because of legal reasons." So for them, it's an essential boundary condition that you use local models, for example. So yeah.
Yeah, amazing. That was another just packed with information on that. I had seen a tweet today that was like benchmarking like Cohere's language model with OpenAI and Anthropic on query rewriting, right? So like, and then it was reporting that Cohere was the best language model for this, and it's so fascinating that for each of these steps in the program, like infer and rank, and I really want to just keep it in the 2 layer. I know it can get like 6 layers, but it's just so hard for me to quickly think about that. But like with this infer rank, the two LM parts, maybe Cohere is the best language model for inferring and then also for teaching. And then maybe some other model is the best of that other task. That kind of like which LM for which task is super fascinating. And
Yeah.
yeah, yeah, the
So
way
so
that,
he, I just want to layer one thing on top there. We've kind of decided on the fact that which LLM you take for which task is an important parameter, but it's also just a discrete choice, just like the demonstrations. So given enough data, it might even make sense to have heuristics for picking which language model for which module. So then we're going really deep into the optimization, right? We're even optimizing what the underlying API is.
hmm.
Yeah, just want to throw that out there.
Yeah, I hope this isn't too off topic, but it makes me think like, maybe you could argue that, like, say, PyTorch Lightning, now Lightning AI, like maybe because they have seen so many workloads that they could kind of like bake in some momentum parameter on their optimizer. Like this is kind of the analog it's making me think of. Like, you know, may, like I don't think that kind of thing has emerged. I'm actually not sure. Like maybe OpenAI with their kind of like closed experiments, they've seen so much data and they've trained so many models from scratch that they also have. Well, actually, now sorry, I'm kind of talking myself into realizing that they do have this. They have like optimal, like there's generally like learning rate is like a pretty consistent thing. I think like 10 to the -3 or something like.
Yeah. So what I want to say there is, let's say you want to do some conventional fine tuning on a sequence-to-sequence task. You go to Hugging Face. Your architecture has already been decided for. It's either an encoder-decoder model or it's a decoder-only model. So now there's two training scripts you can consult at Hugging Face. The hyperparameters have already been decided for, like what the options are. You know that learning rate is the important one to tune. You know that batch size, you should just care about what your memory can handle, all of that stuff. Then you go to a forum and you find that somebody said that, oh, this learning rate was the best for FLAN T5 XXL. And, in that whole pipeline, so much community and wisdom of the crowd knowledge has happened without you actively thinking about it. Um, and and kind of that's what I hope for in the long term for this work, is that there are just good inductive biases baked in into how do you solve such a problem with pre-trained components, and somebody can just come along, take my script, say like, oh, no GPT-4s. I have Ollama running here on this URL. I want to maximally do like 10 calls of Llama per input. Go. Um, that would be the dream. I would very much like my work to get at that point. Yeah.
Yeah, amazing. I'm completely sold on that now. But I guess I have one more question where it's like, uh, can I bootstrap, say I bootstrap 50 examples and now I fine tune a model on those 50 examples and then that model is the teacher going forward. Is that a pattern that you think would have value or?
That is interesting. That is interesting. because typically I've been thinking about fine tuning as more of a mechanism towards the student side, where you get a smaller model to mimic the behavior of a bigger model efficiently. Um, so the reason why, yeah. So let's say you have like let's just think through this, right? This is interesting. So let's say you have your teacher model generate the 50 best quality examples. If you then fine tune a model on that, it's probably never going to surpass the teacher. So without some other ideas, it might not, it might not. And if it already mimics the teacher perfectly, well, then that's just the ideal student.
Mm,
So I need to think about this more. I've been thinking about fine tuning mainly as a student type
mm.
thing to improve latency and costs at inference time.
Yeah, I guess that like on one end there, I think there was like some meta knowledge distillation stuff from Jeff Hinton. Like I think I want to say it was like 2 years ago. This is the kind of like the meta learning. I think meta pseudo labels is maybe the name of the paper, where it's like it's pretty meta where where you're you know optimizing the teacher to train the student, and so the gradient from the student like comes back to the teacher.
Yeah. Oh, yeah, that kind of stuff. Yeah, and then you have like second order grading. Yeah. Um, there definitely are applicable concepts to DSPy that I've been thinking about. I haven't had time to figure them all out, but and I know some other people, at least at Stanford that I've talked to, are thinking about similar things in different contexts. It's yeah, you shouldn't necessarily just the current paradigm we have is you look at which examples are good for the teacher, then you map those to the students. Um, there are a few pitfalls there. For example, trivial examples will be trivially completed by both the teacher and the students. So you should never waste optimization cycles figuring out if adding a trivial example to the student improves performance. So maybe you don't actually want to pick traces of a good teacher. You maybe want to pick traces where the teacher is much better than the students. So you would take both of their performance into account and you're like, okay, actually the teacher did not fully solve this problem, but because we have like a granular metric, it did solve it much better than the students. So actually our heuristic tells us that this is an informative example, even though the teacher didn't fully solve it. And so that is already taking a bit more like the dense interaction you could get between like the teacher figuring it out and the student making like their unique errors based on what the teacher said. So that can kind of embody that meta vibe you're going for. I don't want to spend that time like passing gradients through like other models and then, but maybe who knows? Yeah, it's a very interesting idea.
Yeah, well, I think you've already kind of like inspired my curiosity with this idea that like the most thorough rationale isn't necessarily the best training example for like T5 700 million parameters, and I mean that already kind of opens up the box so much.
Yeah.
Yeah. But I kind of being mindful of the time. I think we did. I think that was an awesome coverage of the optimizers. But I have another question I really want your thoughts on, which is the kind of the design of these programs. Like you've designed the solution to extreme multi-label classification as Infer-Retrieve-Rank. Did you maybe consider adding another component to it? Like what led you to settle on those three?
Yeah. A kind of, um, they seemed like the minimal set of solutions that would be conceptually very satisfying. And we have ablations in the paper where it's like, what if you don't compile this module, or what if you delete this module? So like going towards simpler pipelines, we have like the full set of results. But then going towards more complicated pipelines, well, it's just all open ended. Like it's the Wild West right now. So um, one thing that I know or I feel very strongly will improve performance is some kind of chunking or ensembling logic. So, for example, when I'm dealing with full medical papers, as I am in one of my tasks, um, that just doesn't fit in the context window. So we might need to run IReRa 5 times, and then we need to figure out what is now the optimal way to merge the ranking. Do we merge the queries and then retrieve once and rank at the end? I've actually tried something like this, and the initial results were quite bad because all the gains you get from ensembling in the initial step get filtered out because the ranking is like, I don't see any evidence for this, and it throws it out because it can't view the entire evidence everything came from. So another idea is, yeah, applying IReRa to each of these chunks, and then maybe having a kind of macro level rank step at the end, which is either a new language model, but it could also be a kind of mixing components, like a kind of weights that learn how to mix the rankings or something like this. So definitely in terms of just extending the context window, you could add summarization, you could add this kind of like macro ranking. I think that's definitely the first successful iteration on top of IReRa, or at least the highest chance of like success, or at least I can conceptually motivate it. Yeah.
Huh. Yeah, that's amazing. I guess there are kind of two things I want to break apart of that. Let me maybe start with the summarization thing. Like one example when I was playing with prompts is, summarizing these podcasts. And so the first thing I would do is go by chunk to come up with the topics. And then I would use the topics to then again go through the chunks to be fleshing out the topics. And I found value in it seeing the full scope of the podcast as it was writing it. And so that and I think like the work that I think Jerry from Llama Index deserves the credit for, like, I think the paper is now called Raptor with this kind of like recursive summarization, but in my opinion I think Jerry deserves the credit for like evangelizing this idea of like
Mm,
summarizing the chunks and having this like local, like you will write a summary of these clips, you'll receive the clips one at a time as well as a summary so far, and then and so yeah, I
yeah.
think that's so powerful. But if we could discuss further this like ensembling the ranker. I find that to be really
Hmm.
fascinating, especially in the context of Weaviate and vector search, because with our re-rankers, it's like I could parallelize the calls to the LLMs. So I don't think I'm suffering. I mean, so I don't think the latency would be hit too much. I mean, now let's say I'm making 5 calls, so I will pay 5 times as much. But if I fine tune the rankers, maybe that's not so expensive. But this kind of ensembling the LLM components, yeah, can we maybe just kind of get a little more perspectives on that? Like, what would make each LLM have a unique prediction to begin with that would be worthwhile?
Yeah. Yeah. So for full papers, like for this task of like finding reactions in papers, we know that there can just be information throughout the entire body of the paper that's really relevant for this task. So we want to process all of it. So we just kind of know from experiments there that getting more context into the model, as long as the model can learn, when we were doing fine tuning initially in the previous work, helps. Um, so that's already the intuition that we actually want to scan the full paper. Um, but then the idea is, do I program how this needs to be ensembled? Because like you've said, ensembling incurs costs. So we also don't want to like waste time by just running IReRa and cost like 10 times, right? So like I've already said, for some tasks, it might make sense to like first maybe just ensemble the llama, the cheap llama in the beginning. We'll run the llama 10 times. We'll get, 10 times as much queries. We'll group those queries. We'll push them through the retriever. And then instead of having a rank module that's like filter out everything that's not true, maybe we should have a rank model that's filter out, everything that could not be applicable, giving like the abstract of the paper. Like we do a more soft filtering. And maybe that's the most efficient performance budget trade-off. Um, I'm kind of still thinking about how do I program these things so that people can just decide this for themselves. So that people can just be like, hey, I want this entire pipeline run across chunks, and I want to learn weights to like group the final rankings. Or I just want to run the first module 10 times and then maybe the second module twice. What is a good paradigm for doing this, and how can you like learn to do this across a bunch of tasks? I guess that's what I'm interested in when I hear this question.
Yeah, that's exactly where my thinking on this is going too. Is like if I want, let's say I'm having each of these LLMs write like a tweet based on the same. Let's say they all take the same input, and I want diverse outputs, and that's sort of the purpose of the ensemble. Then I feel like with DSPy's syntax, I can't just have one signature for all five of these tweet writers, right? Because then they're all going to have an identical prompt.
Yeah,
It,
but there is temperature, right? So I guess the idea is that your prompt really embodies what you want the language model to do. And if you want variability because you're exploiting an ensemble, then every time you send it through with the exact same prompt, you give it a different temperature.
yeah, wow. So maybe that's like, so with the DSPy programming model, maybe that would be, because I think so. Right now, there's like the DSPy dot predict, and chain of thought is interfaced that way. Maybe ensemble is already kind of interfaced like that, and I'm just not aware of it, because I think that's kind of the abstraction that might achieve that. Yeah, and yeah, I'm sorry if that's already in there.
No, no, no. Well, so what is in there now is you can, when you're running a chain of thought or when you're running a predict, you can give a number of predictions value. Just as when you ping something to OpenAI, you can say, give me 10 continuations. So that's that thing. But then you get 10 sets of queries, for example, for the infer module. That doesn't really fully solve what you're trying to do, because how do you then resolve those 10 sets of queries? So actually, I've noticed that, the precision of my ranking will actually drop when I ensemble, because there is more variability. So the chance that there's like one distractor query that like ruins the top two or the top three of my final ranking, that increases. However, if I look at like the recall 100 of my query, that increases when I ensemble, right? Because I am also finding more esoteric terms that are correct. So even just ensembling is just not always better depending on what you want to do. Um, so there need to be like smart ways of, depending on the metric, figuring out somewhere interpolating between not ensembling and like full ensembling. Um, that definitely, as far as I understand, is not an out of the box feature of DSPy.
Yeah, oh yeah. Well, yeah. I think generally just kind of us mapping through the philosophy, regardless of what's implemented in there. It does sound pretty tricky. I guess because it also inspires me thinking about like multi-agent frameworks that I might want to use DSPy for, and I guess that kind of has the look of an ensemble. Like if I want to have like a society of coders and reviewers, and so I want them to each have like slightly different training data or slightly different prompts, such that there's some
Yeah,
diversity in my population.
yeah. Interesting. Yeah.
Yeah, so yeah, the whole thing is just so interesting. There's so much to DSPy, and I'm just like so excited with exploring all these things. And yeah, so I think that was a really good coverage of all these things. I get one other thing I wanted to ask you about was recommendation as extreme
Mm.
classification, because yeah, we're super excited about trying to see how vector search can be used in recommendation. I think this IReRa program would be absolutely useful for recommendation.
Yeah. Um, so recommendation is also very interesting because I feel like there's already a huge body of literature there. I feel like first some of those first commercially viable deep learning systems seem to have been like, or machine learning at scale systems seem to have been like these recommender things. Um, you can definitely frame recommendation as extreme multi-label classification, right? Given an input, given an Amazon product, and the label space is every other product on Amazon, you know, find the ones that are relevant as well for the user. And there is actually a repository out there that frames a lot of these recommendation systems actually as extreme multi-label classification. Um, can you do? Will you be able to do it with an IReRa type program? I think definitely yes. The question is, will it be viable? At the scale that these recommenders operate on, millions of movies, gazillions of tweets every day, maybe even one llama call per tweet is just too much. So maybe there it really makes sense to go for these like scalable collaborative filtering or some kind of like fine-tuned retriever. Um, that is just initially what I would worry about when I were tasked to do a recommendation with this type of thing. I think vector databases for sure really important for recommendation. Just embed everything and collapse your search space from a million by million matrix to like 100 candidates per item. Um, that's already really important. But if it's like one or two llama calls per item per user in one of these like billion user systems, uh, I don't have experience at that scale, and I don't have that amount of compute, so I don't know. So I'd really focus on efficiency there, I guess. But the nice thing is indeed like some of the cold start issues maybe are solved, right? Because when you're fine tuning a retriever, new items always come online. It's very, you gotta like keep the retriever rolling so that you can recommend the new things. The nice thing about this in context thing is that it will very flexibly adapt itself to like new movie. Maybe you can give like the description of the new movie, and it can like make some initial judgment about what types of people will like this movie. Yeah, there's definitely ideas there, but I think I worry a bit about costs. Yeah.
Yeah, I think that's absolutely fair. I guess like, well, yeah, I think if you're worried about latency, then I don't know if the LLM re-ranker has a place in that if that's your main problem, but I do think there's a big opportunity for like more offline recommendations that this can satisfy. Like particularly something that reading your paper inspired me to think about was, say I grabbed the last 5 tweets from Karel, and then I retrieve from Weaviate's database of blog posts, and then now I'm ranking them for blog posts that I'm going to show you to try to, get you on the
Yeah.
Weaviate train. And so then my question to you for extending that would be, I'm very interested in these sequential recommendation systems that kind of model the sequential problem of like, I showed Karel this article of, let's say Weaviate's RefDevec, and you viewed it for 2 seconds. Then I showed you another recommendation. You viewed that for 1 second, but then I showed you something about HNSW and you read that for, 3 minutes. Now it's like, oh, let's more vector indexing stuff. Right. So I really like kind of like,
Yeah.
yeah.
So yeah, that is really interesting, and I think definitely having language models in the loop there is really important. Um, for indeed for the kind of like conversational or sequential nature of this process. Kind of understanding in context, the user has already been exposed to this. Therefore, their prior, they have different beliefs about the world now or something like this. So therefore, I mean beliefs about the world in like the technical sense, not in like the political sense or something. But it's like, oh, given that the user understands this, or given that the user is not interested in this, that makes more sense. Um, yeah, I need to think about how such an agent would look like. Like, how do you continually keep injecting new states of the user, and how does that influence the whole like retrieval and ranking downstream? Um, but that does seem to require some type of flexibility that I feel that language models are adept towards. I say that as somebody that has no experience in recommender systems, but that's my 2 cents.
Yeah, well, I think it kind of reminds you of like model-based reinforcement learning, kind of like how you have this model of what you predict the next state transitions to be. And I think the tree of thoughts prompt is kind of similar, where you're kind of like where you kind of roll out potential futures. And yeah, so yeah, just
Yeah.
something I think that would be a huge application for IReRa. I think it already is super powerful for the idea, I think, of taking the last 5 tweets as the initial query and then
Yeah.
map that into the retrieval and then re-rank it. And yeah, and the recommendation thing is super interesting. So, Karel, as an anchoring question, I really want to ask about your interest in biomedical NLP and what kind of
Yeah.
led you to pursue that.
It's so interesting. Well, it's interesting to me. The PhD is it's such a roller coaster. You never know where you're ending up or what you're doing. But that's the fun thing. That's why I absolutely love it. I got into this via, and we were talking with my advisors and this company that actually tries to solve some of these problems, specifically of like drug safety monitoring. So we cannot check as a society. We cannot check everything about a drug, a medicine during the clinical trial. Nothing would just get released. So a compromise we make is that whenever doctors write about something like, hey, Connor took this medicine and actually he ended up having an adverse reaction. And maybe this reaction wasn't even known to science. So doctors will write this in papers, in clinical studies, and all of that information will just be out on the internet, but like unstructured. And pharma companies that produce drugs, at least in the United States, are actually required by regulation to look at a certain query over all the biomedical literature in order to read it and like figure out, did something happen with our medicines? So every time you and I, every time we're taking a medicine, we're kind of relying on the fact that the latest and best scientific study has been like viewed and like people have extracted this information from it. It's all in a centralized database, and a ton of different researchers are using that database to like study whether or not there are like statistical anomalies with drugs. So there's like a whole real world system running perpetually. And I was fortunate enough through collaborators to talk with some of these people doing that work. And this is just, experts, a pipeline of experts looking at these papers, consulting databases, doing searches, consulting even the authors of publications to do this, right? And so it felt so inspiring to us. You're dealing with long context. You're dealing with an immensely high stakes situation. You are dealing with biomedical knowledge. You're dealing with tasks that need like multiple humans in the loop to resolve. How good are our language models at this? So then we made like a big data set for this, Biodex. And we found that actually one of the things language models were really bad at was like speaking the exact terminology for these medical reactions. And that's kind of how I got into touch with Omar. I was always like fascinated by his work. And then, we just started thinking about it, and one thing led to another. Then we're like, well, we can not only do this on biomedical things, let's also get job vacancies in there. And then it kind of grew into this, let's generally try to solve this problem as best as we can across the board. But yeah, that's been the arc here. Yeah.
It's amazing. Karel, thank you so much for joining the Weaviate podcast. It's so cool to hear about your story of getting into biomedical NLP, the problem you just described, and all these things with DSPy. I mean, I think there's so much to this podcast. I'm personally just so excited to rewatch it and digest it. And I'm so happy to be publishing this and presenting it to our audience. Thank you so much, Karel.
Awesome. Thank you, Connor.